Multiply the divide radicals. Previously, we have learned how to combine radicals. When we say combine, we mean plus or minus, just like combine like terms. So it's like add or subtract radicals. These two types of questions are very different. Just like for addition or subtraction, say 2x plus 3x, we get 5x. X doesn't change. We only add the numbers in front of them, and because it's like 2 copies of x plus 3 copies of x, we get 5 copies of x. But if we do multiplication, we're going to get 2x times 3x. We will multiply 2 and 3. We will also multiply x and x because it's all multiplications. For multiplications, it's not going to be like combining like terms anymore. X times x will give us x squared. 2 times 3 will give us a 6. So addition, subtraction are different from multiplication, division. Similarly, for radicals, they're also different. So recall the examples we did before. Say if we do 2 square root of 5 plus 3 square root of 5, we're going to get 5 square root of 5. We are adding them just like we're adding 2x plus 3x. So you are treating the square root as a variable x. So 2x plus 3x, we get 5x. But of course, we don't have x here. We have the square root of 5. And we just keep it as a square root of 5 instead of using the x. So when we add radicals or combine radicals, we add the numbers in front of them. And we keep that radical, just like we keep the variable. But again, multiplication will be different. So if I want to multiply, that's the topics for today, that's a new thing. If I multiply 2 times square root of 5 times 3 square root of 5. Now notice that the biggest difference is combining like terms. This is like 2 times square root of 5 plus 3 times square root of 5. And there are many different ways to look at that. So there are two operations involved here, multiplication and addition. But for multiplication, there's nothing you can do because 2 times square root of 5, we cannot really combine multiply 2 and 5 in there because 2 is out of the radical and 5 is within the radical. And so that's we could, although we have multiplication, we couldn't multiply them, just like when we have 2 times x, we cannot really multiply 2 and x because we don't know what x is. And so we just do addition, and when we add things like this, we keep x. We add the numbers in front of them because if this 2 times x means 2 copies of x, 3 times x means 3 copies of x. Together, when you add them, you get 5 copies of x. And so the same thing for the radicals. But when you do multiplication, notice that we don't have plus. The only operation we have is multiplication. And multiplication has a commutative property, which means we can switch this x and 3, put 2 and 3 together to get a 6. These two x together to get x squared. So we're going to do exactly the same thing like that, multiplying the polynomials, monomials, and we are going to multiply. So we can use the commutative property again because it's multiplication. Multiplication had all multiplications, and we are going to multiply 2 and 3 to get a 6. And then we can multiply, let me slow down to write down the step here. So after we switch this 3 and the square root of 5, we're going to get 2 times 3. And we're going to get square root of 5 times square root of 5. And then 2 times 3 gives us a 6. Square root of 5 times square root of 5. Because both numbers, these two 5s are within the radical sign, we can multiply them to get 6 and the square root of 25, which is 5. So the answer is 30. So for multiplication, yes, we can multiply the numbers with the radical sign, but not for addition. If we are asked to add them, you cannot add square root of 5 plus 5 to get square root of 10. That is completely wrong. square root of 5 plus square root of 5 to do addition, you combine the like terms. So this is treated as 1 times square root of 5 plus 1 times square root of 5. We combine the numbers in front of them. Correct answer should be 1 plus 1 is 2 square root of 5. We cannot get square root of 10. The reason behind this is, so why can we add if it's multiplication, we can multiply the numbers within the radical sign, but addition we cannot add the numbers within the radical sign. And that goes back to the exponential rule. If you remember, we learned that if we have, say, x times y to the nth power, we can raise each of them if it's multiplication. Let's just make it easier to do square. We can get x squared times y squared. But if it's plus, if x plus y squared, we cannot get x squared plus y squared for addition or subtraction. So this is wrong, but this is correct. When you distribute exponent, it has to be multiplication, or division also works, but not plus, addition or subtraction. So this is sort of similar, because in the later section we will talk about square root of 5. Just kind of to give you explanation, I have to use a little bit something we can talk about later in later sections. So this means square root can be written as exponent as 5 raised to 1/2. And so when we do 5 raised to 1/2 times 5 raised to 1/2, we can get 5 times 5 raised to 1/2. Because after we distribute the exponent, you get 5 raised to each one. But not for addition. If we have 5 raised to 1/2 plus 5 raised to 1/2, we cannot say we add 5 and 5 raised to 1/2, because you cannot distribute the exponent to them if it's plus. So this will be wrong, but this is correct. But if you don't want to bother to about all this explanation, I think later in later section you will have a better understanding of this. But at this moment, what you have to remember, adding or subtracting is just like combining like terms. You can only add the numbers in front of them. You will keep the square root. You cannot add the numbers within the square root. But for multiplication, we can multiply numbers within the square root. For division, we can also do that, but not for addition and subtraction. Okay, so let's look at another example. So let's call this one example 1. We have negative 3 square root of 2 times 4 square root of 7. So similar to the previous example, we're going to multiply, because again, there's nothing here but it's actual multiplication. So we can switch these two and put a negative 3 and a 4 together. So we multiply them to get negative 12. And then we can multiply square root of 2 and the square root of 7. And for multiplication, we can multiply the numbers within the radical sign to get 2 times 7, which is square root of 14. And notice square root of 14, that 14 does not contain any perfect square. It does not have 2 copies of anything. And so this is already in the simplest form. Now let's look at the next example. What if we multiply square root of 3x times square root of 15xy minus square root of maybe we can do another 3 x another 3y. So when we do multiplication, first of all, look at this parenthesis. What's in the parenthesis? There's a subtraction, but these, when we add or subtract radicals, we have to make sure they match, just like terms, but apparently they don't match. One of them has y, the other does not have y, and so they're not like terms. We cannot subtract them. But notice there's multiplication here. We can distribute. This is the distributive principle we learned before. We can distribute what's on the front to each one in the parentheses and to do the multiplication. So subtraction cannot be performed, but we can perform the multiplication. First, I'm going to slow down here. Later on, you may be able to skip this step. So we distribute this to the first one. So we're distributing square root of 3x to the first, and then subtract square root 3x times square root 3y. If you keep forgetting distributing something, I would put the radical you're going to distribute on top of each so you don't forget. So I'm going to put a square root 3x on top. So you're multiplying these two. That's how I get that. And you're multiplying these two. Okay, next we're going to multiply. For multiplication, we can multiply the numbers with the variables within the radical sign. Let me put the numbers together, 3 times 15, and put the variables together, x times xy. And subtract 3 times 3 and x times y. Now let's simplify each radical. Because we're doing square root, we need find 2 copies of anything. So 15 can be factored as 3 times 5. I'm going to keep the other variables and just maybe copy this and simplify these two together in the next step. And some of the steps can be omitted if you can see the answer. So there are 2 copies of 3. These 2 can be taken out to get a single copy. And there are 2 copies of x, so these 2 can be taken out to get a single copy. Use a different color. X. And the other 2 have to stay because they are not squares. Now similarly, here we have 2 copies of 3 that can be taken out, but x, neither x nor y have 2 copies. They have to stay. And the next step, let's see the subtraction. And apparently these 2 radicals, they don't match. We cannot subtract them. So in order to subtract or add radicals, we must make sure whatever within the radical sign, they have to match. Apparently 5y and xy, they don't match. That means we cannot add or subtract them. So this is already in the simplest form. In next example, we're going to look at what if we have a cube root. So the way we do it is still going to be the same. So first of all, these 2 cube roots, they don't match. We cannot add them because they're not like terms. But multiplication, we can distribute that to both of them. So we're going to have 3 cube root of 2 times 4 cube root of 5 multiplying these 2. And then distribute it to the second one, plus 3 cube root of 2 times cube root of 7. Now, when we multiply, we're going to multiply the same way. The numbers on the outside of the radical, 3 times 4, it's 12. And numbers on the inside of the radical, 2 times 5, that's 10. And similarly, 3, that's the only number, but under the cube root, we have 2 times 7, which gives us 14. And these 2 radicals, they don't match. They both are cube root, but the number within the radical sign, 10 and 14, they don't match. So for addition, we must have a matching radical to combine. So that's the final answer. And also, 10 does not contain 3 copies of anything. 14 does not contain 3 copies of anything. That's why we have to stop.